them in the wrong room. Anyway, that's all the comedy. Please be seated. You are all seated. There's a couple of seats over here if you guys want to come sit down. Switch off your phones unless you're tweeting, and if you are tweeting, that's the hashtag. That's the end of the comedy, honestly. Right. So, a little introduction about me first. So that's me there. I'm going to have to stand here. My big fat head in the way because I've got notes, and I keep changing the slides like once every couple of weeks because things change. That's me. That's where I am on these places. And I currently work for Moo.com. Hands up, heard of Moo? Hands up, who's got a Moo product in their pocket. Oh. That's not bad, that's not bad. So we make business cards and letterheads and that kind of stuff. It's premium stationery. And we've got 5 teams, mostly doing Scrum. One's doing kind of a Kanban-y, Scrummy thing, and the other one are just doing whatever the hell they like, which kind of works for them because they're quite small. Today, I've got one of these. So today we're going to be talking about what is estimating, the problems you encounter with estimating, a bit about planning, so the output of estimating or use of some of the estimate, and then at the end, like what does it mean? What is estimating for? What do we do? Like we said, if you have any questions, ask them straight away because I'm going to go straight up to 4 o'clock. Be very verbose. So if you have any questions, ask immediately because they'll be in context and it's easy to answer them that way. So first things first, take a quick look at that. 10 seconds. This is Hume's Treatise of Human Nature, which is some philosophical thing. Please don't read it. What I want you to do is I want you to estimate how many words are on that screen. 5 seconds. 4, 3, 2, 1. Good. Right. Your estimates on your post-it notes. Pass them this way across the room so they get to this end, and then pass them all the way down to here. And this lovely gentleman on the end will read them out for me later. If he doesn't want to, he can swap. Yes? If you don't have questions, don't worry, because I won't get to do all of yours because it's a big crowd. So. Right, so let's crack on. You can do that quietly. So what is estimating? Well, Wikipedia, settle down, it's a post-it note. Wikipedia says that estimation is the process of finding an estimate or approximation, which is a value that is usable for some purpose, even if input data may be incomplete, uncertain, or unstable. So you may be thinking to yourself, well, that's just guessing, right? Well, yes. A guesstimate, says Wikipedia, is defined as an estimate without using adequate or complete information, or more strongly, as an estimate arrived at by guesswork or conjecture. So yes, it is guessing. Okay? So the problem we have with estimates are few and many in the same sentence. The first one we have, and hands up who's experienced this, is having just one person do the estimating. Who's had this in a previous company or in a current company? So you normally get like a domain expert or a lead engineer, they go, yeah, that's this long and that's that big and that's a terrible way of estimating. Terrible way of estimating. Firstly, you wouldn't ask a window fitter to estimate how long it's going to take to wire your house electricity, right? So if you've got your product owner doing your estimating, it's not really going to work that way, right? You wouldn't ask a plumber to estimate how long it's going to take to put carpets in, okay? And secondly, wait, hold on, a bit lost. Yeah, there are 2 reasons. So, low range doesn't work. So we have, what's this? Who can tell me what this is? Jury. I don't know why Michael Portillo is in here. I don't know where I got the picture from, but anyway. Why do we have juries? Why do we have juries? Anyone?
To get multiple opinions?
Multiple opinions, yes. That's exactly it. It's because a group of people are better at weighing up a bunch of information than a single or 2 people. And even if you've got a domain expert, so there's some studies been done on this, and if you've got 2 experts in a particular thing, and they're given a lot of information, and they give an opinion back, it will likely be not as good as an opinion of a group of lay people, right? So when they can use like lay terms, and they're not thinking in such detailed ways as the lay people would be, as the experts would be, so they can come up with a better opinion. So people often talk about groupthink as well, which is a social psychologist, Irving Janis, in 72 came up with this idea of groupthink, and it's where a group of people make faulty decisions, because there are pressures on them. because of the group. There's mental efficiency, reality testing, and moral judgment. All these things become much harder to do, and in some cases impossible, when you're in a group of people. Groups ignore rationality. They're making irrational decisions because of this idea of groupthink. And people are especially vulnerable to groupthink when they are of the same type of people. So a bunch of engineers, for example, or a bunch of product owners, or a bunch of people who do similar things, have the same background, are more susceptible to groupthink than a broader array of people, such as a jury, where they're made up of lots of different cross-sections of society. So the symptoms of groupthink are as follows: the illusion of invulnerability, and this is where there is excessive optimism. And I'm fairly sure that, I know that I've done this in teams, and I'm sure that some of you have done it, and you can go, yeah, definitely, that is totally a 2. Or that's only 2 days, or I can do that in 10 minutes. And everyone else goes, yeah, we can totally do that. Actually, it's not, right? It's much longer. People get excited, and they overestimate their ability to do things. There's collective rationalization, where members will discount warnings external to the group. So somebody will go, yeah, somebody outside of the group will say, have you thought about that? That seems like that problem there might apply to the thing you're doing here. And they go, no, don't worry about that, it's fine. No, not at all. There is belief in inherent morality. And I know that I've been in groups of engineers where they've done this, where it's like, no, we're right. Of course we are. We're the engineers, we're the guys doing the work, so we must be right. Stereotype view of outgroups, this is simply the enemy. So which is often perhaps marketing, or product people, or customer services, or these others, these enemy people who want us to do this work. We've all fouled to this, and we start applying negative connotations to those people. We have negative thoughts about them, and that changes the way we think. Direct pressure on dissenters, which is as it sounds. There's pressure on people who will say something different. So, for example, there's 5 people in the group, and one of them is going, no, it's X and not Y. Everyone else goes, shut up, no, that's wrong, you're absolutely wrong. And that causes people to just keep quiet and not interact later on down the line. Self-censorship, similar kind of thing. It's the flip side of that, where if there is pressure on you, then you might not say something because you don't want to stick out in the group. You don't want to be the odd one out, the guy who is always wrong, or the guy who's always different. So you will censor yourself. Illusion of unanimity. Somebody pronounce that word for me. Unanimity. Illusion of this, which is the majority view and judgments are deemed to be the same for everybody, right? So everybody will be sitting in there thinking, well, everybody thinks the same as me, so there's no point in me saying this thing. And there are self-appointed mind guards. So you'll often have a team leader, or somebody in this position, or just a big mouth with a huge opinion and a massive ego, who might say, who might be given a piece of information outside the group, and they think, well, I won't tell my team that because it's not relevant, just because they think it isn't, it might be. So these are things definitely to be aware of with groupthink. And the longer a group of people stays together, the higher chance that this stuff will happen. So it's good to be Agile coaches, Scrum Masters, people like us, and other engineers, and all the people in the industry need to watch out for this kind of thing, because it will make the process of estimating completely pointless. Okay? So, a bit of history of estimation. So, who's this? 45, because he's... I'll explain in a minute. So 1944, the Delphi method was developed to forecast the impact of technology on war. So forecasting at this time is difficult because there are areas of scientific law that just haven't been established yet. And so when we were doing research, like radar is one of those, when we were doing research on this kind of stuff, we didn't know that the scientific laws, and so estimating how long something might take to do, or what we need to do something, became a very, very difficult task. So there are a panel of experts distributed globally or nationally, or wherever they were, not in the same place, would be sent out a questionnaire, and they would answer the questionnaire, fill it in, they would send it back, and then some guy or gal would take all those answers, write them as one paragraph summaries, and then distribute them out again. And then everybody, all the experts, were then encouraged to revise their initial answers based on the summaries they'd had from everybody else. And this would keep going around and around until they came to one answer. In the 1970s, we fast forward 30, 40 years, in the 1970s, Barry Boehm, who's a software engineer and a professor of engineering at USC, developed Delphi into wideband Delphi. It was pretty much the same thing, but it was all in the same place. It was all in the same building, at least, in the same university. And it went through much the same processes of peer review and that kind of thing. But this is where our estimation as we know it today started. But how should we estimate? Right? That's the question. That's why you're here, right? Yes? Find out how we should. Good. So, let's come back to this. So this, we need to do this very quickly because we don't have much time. So have you all passed your numbers down? Right, so I want you to read some out for me. Right, go.
300.
Yep.
100.
Yep.
523.
Yep.
160.
Yep.
320.
Yep.
300. 300.
Yep.
85.
85?
Yeah. 1,000.
1,000.
Yeah.
Is that a gag?
350.
350?
150.
Yep. 150?
150.
Yeah.
2,458.
I am not. Yeah, again we've got
250.
250.
220.
Yeah.
272.
Yeah.
500.
Yeah.
Oh, I'm dropping them now, too much pressure.
Don't worry.
220.
Yeah.
200.
Yeah.
270.
I think that'll do. Let's see. 298. That's what we came up with as a group exercise. Even though we had what, 585. Oh, I've got the thing back on. Where's your mouse? Good. So the actual answer was 263. Round of applause, everybody. Well done. So given that we had, so that proves that a mass of people estimating will still be relatively accurate. The closest I've had is 261. And I've made a mistake before. I've had people shout it out, and then they start angering each other, and they all start shouting out the same number. But it still was fairly close. If I'd have put the 5,000 in, that probably would have ruined it entirely. But yeah, so it just shows that you can get fairly close, and it's kind of close enough. If people want to kind of like chop them up and eat them, or whatever we want to do with those words, when the 298 is close enough to 263. So the next problem is estimation is hard. Okay. So how do we do it? How do you do it? Somebody give me an answer. How do you estimate at the moment?
Make it up.
Make it up. Okay, so one of the things we use is ideal time, and this is a horrible idea. The idea that you can say, well, if you have perfect conditions and nothing went wrong, and you can sit down and work on something, how long do you think that would take? Right? And the problem to this is twofold. Firstly, research suggests that when you're thinking about how long something will take to do, you're spending more time thinking about the time it would take to do than the actual task, right? So you kind of be a bit clearer about that. So the actual task is to write a feature or some code for a feature. But what you're thinking about is all the times what time you're getting in the morning and how many cups of coffee you're going to have and that kind of stuff. You don't apply as much cognitive cycles to the actual task itself, right? And the second problem with ideal time is we suck. Humans suck at temporal estimation. We're really very bad at it. This guy, Viaudot, in 1968, came up with this law. Retrospectively, short intervals of time tend to be overestimated. Long intervals of time tend to be underestimated. Right? What? Right. The reason I did that is retrospectively. Right. That means that even if you have already done the task you are now estimating, you will still get the estimate wrong. just sink in for a while. Right. You're re-estimating a task you have already done. You're estimating the task you've already done, and you will still get it wrong. Okay? And this was a while ago. And what he was doing, his trials were around memory exercises, like how long would it take you to remember this string of numbers and that kind of stuff. But all these guys have done similar trials and studies to back up his works, even up to kind of 2005, more recent, I guess. Some of them are about sort of count how long would it take to count this stack of A4 and stuff. So it's not just memory things, it's actual physical things as well. And these guys will back up that information, that result of his initial trial. And this was also called the planning fallacy. I'm not going to go too deep into that because it's a psychological idea that planning is almost impossible. But chill, it's fine, it's not. But I encourage you to have a Google that planning fallacy. It's a good thing to understand. So this all sounds terrible, right? You can't estimate time. We're really bad at doing that, and ideal time doesn't work, and we have to have groups of people groupthink. So what is the actual solution? Well, it's this: relative arbitrary estimates, which is in the book that you got today. It's wrong. It's A.R.E. It says A.R.E. So what are relative arbitrary estimates? What do we think? What do you think?
Comparative estimates?
Yeah, comparative.
Using points.
Points. Yes, good. It is not time and it is not effort, right? It's not anything, actually. It is not anything. No. what it is relative arbitrary estimates. Before we go into that, what they actually are, I'm going to introduce you to this guy. Who's that? Oh, it's Fibonacci. I already know. He was this is going well. He was a super nerd. He was like the original mathematician. He came up with this, the Fibonacci sequence, although he didn't. Apparently, hundreds of years before, some Chinese guy did it, but he just didn't write it down. So you snooze, you lose. He got the Fibonacci sequence, and essentially, have I got a laser? Yeah. What it means is that the previous two numbers are added together, so 0 and 1 is 1, 1 is 2, etc., etc. What we use, and if you've ever done story pointing or poker planning, we use the modified Fibonacci, which starts 0, 1, 2, 3, and then has these numbers here. Why do we do that? Who can tell me that?
Because you can't actually copyright the Fibonacci.
We found the cynic. Yes, that's one thing.
Another answer would be that if you continue with the Fibonacci sequence to say 21, for example, that gives people a slightly confusing message about the accuracy.
Yes, it's very specific. 21, 34, 55, yeah, they're very specific. So the idea is that a size 2 thing is the same size as 2 1s, and so on and so forth, right? But what we want to say with these numbers is that actually this number isn't the same size as that and that. It's actually very big and ambiguous and amorphous, and I don't want to estimate that. I really don't want to say how long it's going to take. So we use this just to say it's big. Like JB was saying earlier about 1, too fucking big, no fucking idea, right? This is what these mean in that context. We don't call them modified Fibonacci, we call them story points, mostly. We call them story points. And so this is how they're broken down. So 1 and 2, like I said, is as big as a 3. This is bigger than a 1 and 2 and a 3. And these are pretty much too big to take into a sprint or to actually work on. If you're estimating stuff this size, then you should probably be breaking them down. So they're becoming these kind of things. We'll come to that in a second. So some audience participation. If you've made eye contact with me in the last 10 minutes, you will be chosen. You? Oh. Come on. 25. Let's have some volunteers. Who wants to volunteer? It's easier if you're on the ends or the front. If you want to come down here, come on. We need maybe 5 people. Maybe 6. If anyone's really keen. Won't take long.
That's fine.
Good. Right, so I'll wait for just ladies to come into here. Actually, I think let's have 2 more. 2 more. Two of you guys, come on. Come on. Great, right, stand for each other. So, who is the... Come on, let me get somebody. Don't get this for free, right? So, who's the smallest? Shortest, sorry, shortest. Helen. Actually, probably introduce yourself. You are? Ed. Helen.
Dave. Matt.
Harry.
Oliver.
Roy.
Right, known as A, B, C, D, E, F, G. So B is the shortest. Who's the next size up?
A.
A. There you go. Who's the next size?
D.
D. No, what did I write? Did I write A on yours? 2, no, D. So I would say 3. Who's the next biggest?
G.
C. So C.
No, G.
No way.
G.
E. E.
Hands up for G.
Stand up straight.
Hands up for E. Right, E is E, C, D, E. Right, so is E much bigger than you?
Like, frankly, the rest of them are within an inch of each other, right?
Yeah, you're ruining it for me. Alright, so is he he's not that much bigger, is he?
No.
Not that much bigger. So we call him, he's much smaller than this guy though, I suppose, smaller than this guy.
Yeah.
So we can give him a 3, do you think? Roughly the same size, in the same ballpark? Good both anyway. So I'll give you a 5. There we go, and how big are you?
6'4".
Yeah, good. You're probably the same size as these guys here, right? Can you just come and move over here, actually?
Yeah, heels on.
So I'm going to give you a 10.
I didn't want to borrow it off you,
I'm
man.
going to give you a 3. So is anybody not... So you're actually quite a bit shorter than those guys. Like, as if we just took you 3, you're about the shortest. So what I'm going to do is I'm going to take that off of those 2 guys. I'm going to give you both 5.
It's really cold. I don't feel special.
5, and actually I'm going to give you 8.
Oh.
Right, so, we're going to go a number.
It's not a number.
Okay, so where does he fit then? What number does he need?
9.
3. 3?
5.
3 or 5? 3. All right, and there we go. That's relative arbitrary estimation. Right, it wasn't based on anything really. We looked at how tall they were, which is like a rough estimate of how complex a piece of work is. But now they're all sized, right? They all have their estimates. It wasn't particularly hard work. And you can run this exercise with hundreds and hundreds of stories in the space of a couple of hours if you need to. But now we have all these people. Where's yours? So now all these people have an estimate. That's relative arbitrary estimation. We're using an arbitrary number, right? Which doesn't mean anything. It's not about time. It's not about effort. It's not about anything like that. And it's relative to each other, right?
I have a question.
Yes.
We're supposed to just pitch in, right?
Yeah.
Yeah. How do you do this at the start? With a new team?
Good question. If there's time, I will come to that.
Okay.
I will come to that because that's a very good question. So they're all relative to each other, right? It's not like he took 2 days and he took 2 days to eat because he's quite big. So Helen's only going to take half a day to eat because she's smaller, right? It's not literally. It's just relative, right? Does that make sense to everybody? Yeah. Yes.
Can we put either one on two shoulders or the other way around, see if they're the same size as 3?
We could, yeah. So normally I print out dogs in fancy dress and use that because they're different sizes, but I didn't have time to do that this time. Yes, one more question.
The fact that you're using numbers gives the impression that a 3 is, roughly triple of 1, and 13 is roughly triple of 5.
But yes.
Is that the intention?
Yes. That's the Fibonacci sequence. Okay. So, right, you guys, round of applause, please. Have a sit down. So, in a mature team, that kind of estimation, coupled with velocity, which we'll come to in a moment, allows you to be fairly accurate with your estimates. So I did say there were other estimation practices. So what else is there? There are t-shirt sizes, which can also be translated into goats if you need to, or bananas, or apples, or fruit, or whatever you like, right? As long as they mean something to you. And we use t-shirt sizes usually when we're talking about Kanban. Hands up, there's a Kanban? Yeah, that's really good. Hands up, you practice Kanban. Almost the same number, yeah. So we talk about cycle time, right? So cycle time is how long something takes to get from here to here. And what we do is we say, well, an extra small takes a day, a small takes 2 days, etc., etc., etc. And so if we've got an extra small and a small, then and a large here, then we know that to get to here it's going to take us 8 days. That's how we use t-shirt sizes, goats, fruit, whatever, to be able to do some kind of projection and planning there. Okay, is that clear? It's very simple. Yes.
Why do you need that? You shouldn't can that. You can just go back to the cycle time and say the past 2 months we did 10 tasks, so the next 2 months we did 10 tasks.
Yes, if I am a stakeholder and this is my story here and I want to know when you're going to be delivering it, then you can use it for that. Yeah? Kind of. I mean, all this stuff is open to interpretation anyway. So.
Because you're guessing, right?
Because you're guessing. Because it's very ambiguous anyway. But what you like to do, the kind of nirvana with Kanban, is that all the stories become the same size. All the pieces of work become roughly the same size. So you know that they're all going to move through at the same rate. Okay? So a few tips on estimating and just using these estimates. Don't do overtime. I cannot stress that strongly enough. Do not ever do any overtime. Why?
You're more productive.
What? When?
You're not productive.
You're not productive.
Distorts reality.
It distorts reality, exactly, yes.
You also expect it all the time.
Yes, I expect it all the time. So what this means is that, for example, if you're having a sprint, and in your sprint you said we can put 20 points into our sprint, and you do some overtime and you actually manage to do 34, then your velocity jumps from 20 to 24 points. And so it makes your medium to long-term planning that irrelevant, rubbish, because you can't do 24 points every sprint, because you become burnt out. You might be able to do it for 1 sprint, maybe 2, but eventually you'll burn out and your velocity will completely drop because you'll be knackered, right? Don't do any overtime. Make assumptions explicit. When you're doing estimates, so like we were doing there with these estimates, right? I assumed that nobody was wearing high heels or had false legs, right? Because that would have changed the estimates, right? If I was going to be following this rule, I would have said that. I would say, I'm assuming nobody's wearing high heels and nobody's got a false leg. Because then you can come back to that stuff. So if you misestimated, you'll be able to understand why you did. No anchoring. So this is the problem I came across the other week, which is, and there's 2 kinds of anchoring, but in this context, the anchoring is where, when you're doing estimates, so if you've done estimating, you probably all do the thing when you go 1, 2, 3, or ready, steady, go, and then hold it up, right? Do you know why you do that? because of angle. Because if somebody goes, I think it's a 3, and somebody else goes, I think it's a 2, and somebody else goes, well, I don't really know, so I'm just going to go with a 3 like he said. It means that they're not giving you their actual answer, they're just falling in with the crowd. Back to groupthink, yes.
Also, you don't have a common understanding. Somebody in that group doesn't understand why
Yes.
it's a 3.
Yes, exactly. Yes, that's exactly it. Very good answer.
However,
Yes.
should that not start a discussion around why somebody thinks it's a 3, why somebody thinks it's a 2,
Absolutely.
and shouldn't a person that doesn't know and just goes along be honest and say, I don't know?
Yes, they should,
Yeah,
but
exactly.
they might not be, which is why you might have it. So what you want to do is, all at the same time, hold it up. 3 people hold up 3, and somebody holds up 12 or 1 or something, and then that is their opportunity to go, well, I thought it was this, or I don't know how easy it is. Building slack. Try not to fill up your entire sprint, so if your velocity is 20, try not to hit your 20 points, try to do 18. Because you give yourself a little bit of slack. If you've estimated accurately and you've done your stories, then hooray, you can go to the pub or read a book or something else businessy. If you've misestimated, then what? You don't drink beer at your work? What? Hold on a sec. If you've misestimated, then it means you've got that extra couple of points to kind of fill up the gap if you need to. Yes.
Quick one about baseline and different teams, different points. But what's a useful way of saying, because it's relative to the easiest task or something that's half a day, what would you count 1 as, for example?
I'll come back to that. It was to answer somebody's question about how you start with a new team. Right, so I'll come back to that. I'm going to have to speed up those to get there. So problem 3, being clueless. I have no idea how to estimate this story. It's so new or so ambiguous, I don't really know. So we have what we call spike story, which is still a story, which you can estimate if you like. What we tend to do at Moo and what our previous companies is time box it. So what we'll do is we're going to have a story here, and we're going to give ourselves 1 day to learn more about this story that we don't understand. So this story is do the doodah with the flim flam, right? I don't know what a flim flam is or whether we've even got one. So you give yourself a day to find out about the flim flam, and then that will allow you to help you inform the flim flam story with this spike story. It wasn't very articulate. Did you get it? Good, yeah. So basically you're writing a story to help you estimate another story. And the output of that might be a prototype, might be just research, it might just be a conversation. And you can estimate it because, for example, if the spike story is to see if we've got a flim flam, that might just take you opening up the code base and having a look. If the story is to go and buy a flim flam, it might be a little bit harder. So you can still estimate those things. Yes?
How do you, if you don't estimate, how do you account for there's obviously time spent on it, and therefore it can knock your, it takes time away from other points that might be.
It does, but I won't worry about it because what we're looking for is accurate estimates, not specific. So it's coming in a minute, the law of large numbers, which will cover that. So next problem, getting it wrong. Who gets estimates wrong? Hands up. Come on, we're all friends here. Yeah, of course you do. And me. You didn't hold your hands up. Good. Right. We all get it wrong. Oh no, we get it wrong. But that's fine. As long as you get it wrong consistently. Okay? You can get some overestimated, some underestimated, but they're not so regular. As long as you're consistent with how you're getting things wrong, then things will even out in the end. One way to find out whether you're wrong, I mean, it's really obvious if you estimate something as a 3 and it takes you 6 months. But one way to work out whether you are getting it wrong is, for a while, revise your estimates once you've done the story. Right? So you estimate it, do the work, and then say, well, actually that was probably a little bit bigger than we estimated. And record this stuff, keep a record of what's going on, so you can look back and see how you were estimating, and see if there's any patterns with the stuff that you were misestimating. Excuse me. It might be that the stories are too vague. For example, you're getting build a homepage like we had in the design one earlier. It might be needing a bit more specificity. Is that right? Yeah. About the work, or it might be that there's just not enough information, or you're packing too much in. Okay. There we go. As long as you're getting consistently wrong and right, then you'll be fine. But there is this thing called the law of large numbers. So a company I worked at previously, what we did is we had the average story points per sprint. And this is rolling over 4 sprints. So each of these dots is the average of the previous 4. Right? You'll see it's quite a roller coaster, right? It goes up and down, up and down, and down. But this is not. Each dot here is the average of all the previous dots. So probability map, the theorem of large numbers is that eventually it'll all even out. Okay? So using this in the context of the estimate, if you get some wrong and some right, eventually they'll all even out. Okay? Problem 5 is the misuse of estimates. My father is a builder, and he has always said, an estimate is not a quote. Right? When I go around somebody's house and they say, can you replace my chimney? And you go, no, probably about 500 quid. That's not a quote. You're not writing it down. And so it's not the same thing, right? Because like we said, with estimation is the process of finding an estimate, blah, blah, blah. It's useful for some purpose, and that some purpose is not whipping the developers because they said it was going to be done in 3 days and it's actually taken them 6. Right? That's not the purpose of an estimate. Okay? The purpose of estimating is just to discover more about the story and to have some rough idea of when you think it's going to be done, which allows other people, project managers perhaps, or business owners and stakeholders to work out roughly when they need to launch the marketing campaign or buy the printer. Right? Not estimating estimates. How are we doing? 15 minutes. Not estimating overheads. So these things we tend to forget, right? Nobody remembers the document, let alone estimate the effort it takes to do documentation. We never estimate how long it's going to take to set anything up. We rarely estimate dependencies. Sometimes we'll think about it. That's not quite as usual. And then non-spike research, such as how do I get this goddamn div to center left or to the line left, right? That stuff, don't write that down as well. So always kind of build in some time for this one. Remember, this stuff's going to happen. Okay? Misleading the estimators, this comes back to anchoring. So if you've got a bunch of people in a room, a bunch of engineers in a room, and they're going to be estimating stuff, if they know that there's a really tight deadline on something, or if they know that the client doesn't want to spend a lot of money, or if they know X, Y, and Z about the things they're estimating, then it will influence their estimates. Right, so if they know there's a tight deadline, if they know that it's going to be cheap, and they really, really want to do the work, then they'll tend to underestimate stuff, which is bad because it's underestimating. Right? But they'll do it because they're being anchored, because they're being influenced by external forces. There is no actual real way of getting around this after you can't neutralize this influence once it's happened. So the best thing to do is to, when you're writing the requirements or the work items down, try not to put any of this stuff in, try not to put a deadline in, try not to put, the customer wants a cheaper version, anything like that, okay, because it will influence them. It's not such a huge problem, but it is definitely something to be aware of. So which method is best? It all depends on the context of your project, on the context of your team, of your company, of how you want to do stuff, how big your features are, how your code base is. So there isn't a best method, right? Whichever one works for you is the best method, right? And it might be that you take one of the methods and think, no, I don't want to use story points, I want to use 1 to 10, or I don't use goats, I want to use something else, right? It's all about what works best in your context. That's the important part. So I can't tell you, the best way to estimate, mate, is to do it this way, right? The best way to estimate is to take what I've said or what you've read on the web or anything and then apply it and refine it in your context, okay? So quickly about planning. So we've got our estimates now, we've done our estimates. What are we going to do with them? So these are there's the onion, have you seen the onions of planning? Yeah, the onion's boring, right? Well, the afros of planning, right? So we have vision, which is our long-term, this is where the company intends to be in 5 years' time. We have our roadmap, which is what we're going to do this year, right? Then we have our release planning, which is what we think we're going to do over the next 3 months. And release planning is a quite interesting thing. Mike Cohen wrote about it, and I would encourage you to go and read about that because it's very useful. It's a little bit of upfront planning, but please don't tear me apart. But it is very useful. Then we have sprint planning. Look at that. Wet throw. And we're sprint planning, and we're just going to delve into this briefly now. So we've got our estimated stories that we all did. They're in a priority order, and we need to start working on this stuff. So so this will answer some of your questions here. So we have our gut feel. We're like, well, what do we think we can do at the beginning of? What do we think we can fit in? So we've got these 2 stories. We've got a bunch of professional engineers, and they go, well, I think we can probably do those 2 in the next 2 weeks. All right. So, pop quiz hot shot. If I estimate that a project is going to take me 4 months, and then I plan out 4 weeks worth of work, but it actually takes me 5 weeks worth of work, how much time is that going to add on to the end of my project? What? How? Who?
Sorry?
Month? None? Not got any none? Don't know? Sorry.
You said 4 months.
Yeah, so if you've estimated your backlog, right? Well, if you've estimated the project going to take you 4 months,
Yeah.
and then you do 1 month's, you plan out 1 month's worth of work,
Yeah.
it actually takes you 5 weeks.
Right.
How much extra time does that add on the end of your 4-month project?
1 week.
Your estimate will change.
1 week?
You've got to replan it.
Your estimate fluctuates, so you'll be consistent with overestimating and underestimating. And
Yeah.
with that fluctuality, you should actually even out if your estimates are consistent over time.
Yes, so you've been listening. You've been listening to what I've been saying. That's perfect. The actual answer I'm looking for, though, you are right. But when you're looking at it like in that very basic abstract view, it's going to add a whole month because you estimated to do a month's worth of work. It took you 4 weeks, which is an extra 25%. So you should probably bet on it adding a whole 25% of the whole project, which is an extra month. All right. So, cone of uncertainty, and that little exercise there, which kind of went a little bit wrong. These are the cone of uncertainty, which is created in 1985 as a way of classifying uncertainty ranges in engineering. The same Barry Bowen who did the wideband Delphi was part of this, and he used it to describe what is it? Describe software uncertainty as a funnel curve. It was called the cone of uncertainty in '97, so it's pretty old. It looks like this. So basically, at the beginning of a project, you know the least about it, right? So they took a whole bunch of data from a whole bunch of engineering projects going back decades, and they worked out what the estimates were and how long it actually took through the process of the project. And what they reckon is that leading a project, you will get it between 0.25 and 4 times wrong. The estimate's 4 times wrong, right? So what this means that if you estimate that a project will take you a year, it will actually take between 3 months and 4 years. At the beginning of the project. That's how wide that span is, right? Okay? So, bear that in mind, cone of uncertainty. So we've got our gut feel for sprint 1, we begin sprint 1, and we complete it. We get a velocity of 13. Okay? And the velocity of 13 comes from adding those two things together. So now we know that we can definitely, or we think we can do 13 points in any sprint, right? So in the next sprint, we've got a 13-point story, right? So we're going to just do that then, because we know we can fit that in, right? So we begin sprint 2, and we're successful again. But this time our velocity is 15, because if you add 13 and 14 divided by 2, you get 15. So if anybody was paying attention, we've got 6 sprints here, right? So we took the total of our product backlog. We have to assume that I've added that up correctly. Divide it by 13, and that gives us 6, right? But in the next sprint, we've changed our velocity, which means we've knocked a whole sprint off. We can actually fit more work in than we think, okay? And this is answer to your question. So once you've done one velocity, you have a single data point to be able to work out roughly how much the rest of the backlog is going to take, right? And so when we do another sprint, you're adding new data points and you're refining this data, right? And this will help you project further into the future about splitting this stuff up.
Is it sensible to revise the estimates on the stories further down based on your experience of the first 2 sprints? Because you might discover that a 13 is not a 13 anymore.
Yes, definitely. Yeah, you should always re-estimate. So go when you're in what we call grooming, which is where every week we look at a backlog and we look for the stories to make sure that they're not rubbish, and we can refine the estimates to go, well, actually, now we've done that piece of work, that makes that one much easier, or what makes it much harder, for example. And so you can then refine the estimates, which will keep refining as you go through the project, and it will keep your backlog and your projections that much more specific. Okay? So, in sprint 2, in sprint 2, we've now moved a bit more down the cone of uncertainty. Right? So we're not quite as uncertain, we are still fairly uncertain, but not quite as uncertain. As you go through each sprint, you move, so it was called the cone of uncertainty. This doesn't have a name, so I'm going to call it the spike of certainty. Right? So as we go through the sprints, we move down it and we become more and more certain. To the end, we're like, well, we finished it, so we know that's going to happen. But as you move down, you become much better at estimating. Yes?
Have you read the chapter in the Lecticons of Software Engineering, which discusses the cone of uncertainty and suggests that the data is a lot more subjective than originally the cone of uncertainty. It looks plausible, but the data doesn't.
What's the book called?
It's the Lecticons of Software.
Leprechauns. Already yeah. I am cynical about the name of the book. The Leprechauns of Software. All right, I will look at that and then refine my talk. Thank you. So,
Lord and both of it.
Okay, I'll grab you afterwards. Grab that. So we're going to rattle through the next few because I've only got 6 minutes left. So we have our 8-sprint project. This is a deadline-based sprint. This isn't when it's done, So this has to be done 8 sprints, right? So we've got our velocity, which is 15. So imagine all these had numbers on. So we know, based on adding all the story points up in this list, right? Dividing it by the velocity, which is divided by velocity is 8 sprints, right? It's got to be done in 8 sprints, so we can fit that much stuff in 8 sprints. Okay? With me on that? Yeah. So, what we can do to be a little bit more specific is to work out what our worst velocity is and what our best velocity is. So you take your 3 shittest sprints, and you work out what your velocity is from that, and you take your 3 most outstanding sprints and take your velocity from that. Right? So when you have your best sprints, you put that here, with 20 points, the average is of S3, and whatever I was, I put 10 is the average of the worst 3, right? So what does this tell us? This tells us that we would almost definitely be able to get all that stuff done. Even if each one of these 8 sprints we work the worst we ever worked, we will definitely get all that stuff in. If we work on kind of an average as we normally do, then we'll fit that stuff in. If we work really, really hard and have really, really good sprints, then maybe we'll fit that in, but there is not a chance you're going to fit any of this in. And what this does is it allows the product owners and stakeholders to prioritise this stuff. They might say, well, actually, that one is really important. I really, really must have that, so that we move it up here, we can push all the others down. So it gives them a little bit of a range. And obviously this will change as you go. Like these numbers here will change, so these lines will change. It gives you a rough idea on how to project, yes.
How do you cater for unplanned work, like production issues and something that needs to come into a sprint and you need to look after it?
That is an entirely different talk. We can talk about that afterwards. I think. I've got a few minutes afterwards, so I'll grab you guys. Not really in the scope of this one. So, yes?
How do you convince management to accept points instead of time?
Another very long discussion.
It takes a while.
It takes a while, yeah. It's about basically it's about truth and honesty. Saying, look, we cannot estimate the time. Here is our empirical data that says we can't do it, and so this is the new method we're going to use. And if you get it right, if you consistently deliver stuff, if you consistently do what you say you're going to do, with the odd hiccup, then it looks, then that should be enough. That should say enough for you. Right. So. I'm going to skip through some of these. So after release planning is sprint planning, and after planning is daily stand-up, which is Jackson one. Oh, here we are at the end. Good timing. So, what does it all mean? What does it all mean? So this guy, who's this? Donald Rumsfeld. He's famous for saying what? Unknown. Yes, there are always going to be unknown unknowns in your project. Right? No matter how well you think you've planned it out, there is always something going to crop up. This guy, Dan North, has an excellent talk called Embracing Uncertainty. You should definitely look it up. In it, he says this. Some unexpected bad things will happen. Now, some means non-zero, right? Something will go wrong, right? Unexpected means you cannot plan for it. It is something that you can't decide is going to be there. The unknown unknowns that Rumsfeld's talking about, right? Got too far again. And bad things. The bad things is important because they are things that will negatively impact your project. Hopefully there'll be some unexpected good things as well, but there will be unexpected bad things, right? So what does this mean for estimating? What does it mean? If we're going to do this estimating, there's going to be shit that crops up, then what's the point, right? I think this is where no estimates comes in, right? I'm still not entirely okay with this movement because there's a few contradictory points of view about it. But the answer, what I think fundamentally it is that estimating is hard, it's frequently not very accurate, and you can't estimate for the stuff you don't know about, so what's the point? Right? What is the point in estimating? Because we've just been through this whole presentation, and I've just said to you, it's very fluffy, it's very ambiguous. Often you'll get it wrong, sometimes you get it right, it will help, there's ranges, there's all kinds of stuff, but I'm not painting a very rosy picture about it. Empirical data will help you improve the accuracy of your estimates. So like I said, make sure you're recording your estimates and then retrospectively recording how long you think it should have taken, like a new estimate. Keep this data for a while. You can build your own cone of uncertainty, right? Develop and refine your own models, right? This will all help. This helps make estimation much more accurate for your company and your context, right? Keep empirical data, define your own model based on existing ones. And then there's this guy. Who's this? Eisenhower. Very good. This is General Eisenhower, and he is famous for saying this. I think he said this anyway, it's the internet, who knows. I've always found that plans are useless, but planning is indispensable, okay? So what he's saying is that when you go into your command tent, and you stand with all the people with the brass on their shirts, and you stand there and you push tanks and planes around, right? The thing you come out with at the end of it will very quickly be completely useless. And it's the same for us. Same for software engineers, the same for people who make things, is that it doesn't matter how often you plan, how much you plan, the thing that you spit out at the end will very soon be out of date. But what is really important is the time you spend planning and talking about it, right? A friend of mine, Mike Sutton, said this: estimation is not about the number that pops out, it's about exploring effort and discovering that you don't know stuff. And I think this is where no estimates is about. It's about the numbers that come out at the end help you do some rough projections, right? It will never be specific, you can only ever increase its accuracy. But it's about the discovery, it's about the exploration. I think that's what JB was talking about as well. He was talking about the conversations. Right? That's what you're doing when you're planning, when you're estimating, you're having a conversation. Well, we're going to need to do this bit with the database and this thing over here, and what about that? Well, we should talk with Susie from marketing, she knows about that. That is the important part of estimating, right? Not this. Don't treat this like a religion. Don't bet the farm on this kind of stuff. Just use it for what it is, right? Which is a rough guide. Okay? Any final questions in the -1 minute 12 we've got? Yes?
So why do you call it estimation too? So basically you told me you estimate to make your stakeholders happy. Why do you call estimate something which is a complete guess? Instead of, I do agree with the conversation because that is very much called as a kick-off meeting.
What do you call it? What, sorry?
A kick-off meeting or
kick-off meeting.
Which is not like stand estimate because your stakeholders going to beat you if you beat the volume.
But that's about keeping them up to date with what's going on. And what you were saying, well, I was saying to you about being honest about things. Saying, look, this is what we know right now. The code of uncertainty. What we know right now is this is how long it can take. In 2 weeks, we know a little bit more. So we know it's going to take this long now, or this much less. But it's like fundamentally, like JB was saying, it's about trust and transparency and honesty. It's about saying, look, like, this is software engineering. We're doing stuff we've never done before. It's not building a bridge. We're not making a car. We can't know this how long it's going to take. This is our best, most accurate guess. Just being honest about it. I think that comes down to your question about how do you encourage them to do it. You know, what we were doing is a big fat lie. Right? Telling you it's going to take 6 weeks is a big fat lie. Telling you it's going to take between 4 weeks and 12 weeks is not a lie. It's more ambiguous and less useful for you, I guess. But at least it's not a lie. Yes?
Can I just come back to the question about numbers, which is that there's a difference, there's a very important difference between the number for an estimate and using t-shirt size.
Yes.
So if you use t-shirt size, you know that Excel is bigger than L, but you don't know how much bigger. Whereas 13 and 8 gives you a very specific idea of how much bigger it is.
Yes.
What if you had any insights in when it would be likely to use numbers and when it would be best to use t-shirt size?
So, again, it's all in your context. At Move, we tend to use t-shirt sizes for epics, for big chunks of stuff, like the so-and-so project or the batching project. And so, well, the batching project is an extra large, and this project is an extra small. And then we would take that, and then inside that project, we then have a bunch of stories that we'd estimate. And that's how we use t-shirt sizes. But again, it depends on your context. You could use them as you could translate them into numbers. So you could say an X is a 1, and an extra small is a 1, and a small is a 2, etc. But you might just use story points. So it depends on your context. So if you can be consistent with so if you can say an X takes 2 days, and you can be more consistent about that. An Excel takes 2 days, and you're consistent about that, then you can use it. It's just a way of it's probably a better way of describing it to somebody who doesn't know what story points are.
Stakeholders.
Yeah, it's about domain language. Yeah, it's about, are we speaking the cucumber stuff, right? So are we speaking the same language as they are? Right? So if you can say, no, it's a size 3, they're like, what the hell is a size 3? So, well, it's an extra small, or it's an extra large, or it's a medium. That makes a lot more sense. You're still just comparing stuff, right? It's extra small, compared to what? Compared to my shoe, or what is it? Right? So it's all contextual. I didn't answer your question at all, which was quite confusing. Anything else?
I'm going to stop you there
Cool.
anyway, because we're time out. We need to get
okay.
next one.